Hey all, today we're going to talk more about congruent triangles and their parts. Sorry about that. So we have this theorem, and we fondly refer to it as Cpctc, and that's just short for what the theorem means, and the theorem means that corresponding parts of congruent triangles are congruent. And so that's where we get our Cpctc. That's just saying that if we look at two congruent triangles, the sides that correspond are congruent, and the angles that correspond are congruent. We pretty much talked about that in the last lesson. So if I look at the names of these two congruent triangles, KJI and WUV, if I look at the first two letters, K and W, that tells me that angle K and angle W correspond, and therefore they're congruent. If I look at J and U, those two angles should correspond, and they're congruent. And last, I and V, those two angles correspond, so they're congruent. Those are three pairs of corresponding parts, three pairs of corresponding angles, and they're congruent. And so you could also do it with the sides, so KJ is congruent to WU, and JI is congruent to UV, and KI is congruent to WV. So this should look similar to what we did in the last lesson. So now let's apply this, which is really the important part of this lesson. I have the same two triangles, but this time I give you angle measures in triangle WUV. And I tell you that the measure of angle J is 3x plus 11. So angle J is 3x plus 11. So if I want to find x, this is kind of a similar situation that we've been doing all year. I need to take what I know and write an equation. I know that angle J and angle U are corresponding, so that means they're congruent. Angle U is 71 degrees. Angle J is 3x plus 11. So I write an equation, and then I can solve for x. So I'll subtract 11 from both sides, and I'll divide both sides by 3 and get x to be 20. And all that comes from our knowledge that the corresponding parts in congruent triangles are congruent. Again, we call that Cpctc. Here we have two new triangles, triangle RQP and triangle VUT, and I'm telling you they're congruent using that symbol. And I've given you all the side lengths in UVT, and I've given that side QP is 11x minus 1. So if I want to find x, I need to figure out which side in VUT corresponds to QP. So QP is my middle and my last letter, and so that means the middle and the last letter give me the side in VUT, which is UT. So that means that this 11x minus 1 should be equal to 32. I'll add 1 and divide both sides by 11 and get x to be 3. So I want you to pause right here. I'm telling you ZYX and triangle JKL are congruent, and so I want you to find x given this information over here. So I'm telling you angle K is 13x minus 2. That's this angle. And so if I look, angle K is my middle letter, which means it's congruent to the middle letter in ZYX, which is y, and that's 63 degrees. So I write my equation that 13x minus 2 is equal to 63. I'll add 2 to both sides. And this might get a little messy. And actually I was wrong. If I divide 13 by both sides, I get x to be 5. So another way we can apply that is in the coordinate plane. I have two triangles QRP and QLQ, and they're congruent. and I want to find the length of side LK. Remember, I don't put any symbol on top, so that means find the length of side LK in this second triangle. But I don't know the coordinates for K. What I do know are the coordinates for segment RP in my first triangle, and that side should be the same length as segment LK. So what I can do is I can find out how long RP is, and RP should be equal to LK. And so I'm just going to use the distance formula using the coordinates for R and P. And so I subtract my x's. I'll call this x2, y2. I'll call this x1, y1. So I do -1 minus -2, all squared, plus y2, 5 minus y1, 0 squared. -1 minus -2 gives me +1, and I have to square that still. 5 minus 0 gives me 5. I have to square that as well. 1 squared is 1. 5 squared is 25. And so I find out that the length of RP, which is the same as the length of LK, is the square root of 26, which if you put in your calculator, you get approximately 5.1. So because they're corresponding parts in congruent triangles, you can find the length of one of the sides, and that'll be equal to the corresponding side. I put this here because sometimes you might want to graph these just so you can see how they look, but you don't have to. So I want you to pause here, and I want you to find the length of CH just like we did in the previous slide. So CH corresponds to CE, the first and last letter. So segment CH, the length of CH is the same as the length of CE. And so we can use the coordinates for C and E to figure that out. Call this x1, y1, x2, y2. And so I'm going to do 0 minus 2 squared plus 5 minus 4 squared. And I'm going to get -2 squared plus 1 squared. -2 squared is going to give us +4. A negative squared is always positive. 1 squared is 1 still. And so that gives us the square root of 5. And so if you do 5 in your calculator square rooted, you get close to 2.24. So I have two problems for you to try. They're very similar to the ones that we did in this lesson. Copy the pictures, answer the questions on a paper that you can turn in, put your name on top, and hand it to me before you leave.